All right, so we're going to go ahead and get started with Unit 1 as we're kind of midway through our first week. Unit 1 is going to deal with the introduction to science, so it's going to be a lot of review, especially if you're a sophomore, junior, or a senior. So it'll be a good unit for us to really kind of get our feet wet with how things are going to operate. If you were in the building last year, or if you had me last year, you'll remember, or if you think back, we really tried to start class with a do now. It used to be called a bell ringer, now it's called a do now. I'm not going to have you write it down and turn it in right now. But I don't want to really change things a whole lot just because we're virtually. I still want to try to get your brain turning a little bit, just from wherever you're at or wherever you're watching this lecture currently. So this do now basically I just ask you in your own words to define what you think science is. Okay. Not, again, it's not going to be one of your questions at the end of this video, but I do want you to think right now, what do you think science is? And remember, in my class, there's no wrong answers. I just want you to think for yourself. And I want you to think for yourself, and I want you to be able to justify what you're thinking and why you're thinking it. So again, Unit 1, Chapter 1 is going to deal with Introduction to Science. So Section 1 is actually going to be the nature of science. So some key ideas. The first one is how do scientists explore the world? Second one is how many types of science or how are the many different types of science organized? And what are scientific theories and how do they differ from scientific laws? Excuse me. So what is science? Well, the big definition is science is the knowledge obtained by observing natural events and conditions in order to discover facts and formulate laws or principles that can be verified or tested. That's a long definition, okay? I'm not going to ask you to remember that long of a definition, especially when it can be simplified. So let's simplify it. Look at the definition and let's make it a way by picking out key words that going to help us understand what science is and help us remember it. Okay, so science is the process of obtaining knowledge by asking questions about the natural world. Okay, or even more, or you can simplify it more. You could say science is the process of obtaining knowledge. Think about when you obtain something. Okay, you're doing something to obtain that whatever it is you want to obtain. So if you're obtaining knowledge, you're doing something to gain knowledge. If you're gaining knowledge, typically you're asking questions or you're observing and or watching something to gain knowledge. Okay, so science is a process of gaining knowledge. So what do we use science for? Outside of the high school science classroom, what are you going to use science for? I'm a true believer that you use science or science processes without even knowing that you're doing such. And I'll talk about that more here in just a minute. So scientists or yourself may perform some of these examples, which is directly involved in science. They may find the new aspect of the natural world. They may want to explain a known phenomena. Okay, phenomena is a word that you've probably heard a lot by now. Science can be used to check the results of other experiments, and science can be used to test the predictions of current theories. So just a minute ago, we said, I think that most people use science processes and they don't even realize that they are. For example, if you were walking down the road or riding down the road in a car, driving a car, and you see something. Okay, I know something's a broad term. I hate broad terms, but let's say you see a phenomenon, you see an event. Okay, you see an event in the natural world, and it makes you ask a question: why did that happen, or what happened, or how did that happen, or you see where I'm going with this. I would justify that, or I would not justify, I would categorize that as a scientific process. You are looking at something, you're observing something in the natural world that's making you ask a question. So you, in turn, are getting ready to gain some knowledge, the level of which, is up to you, but you're going to gain a little knowledge about the natural world based off of phenomena that you witnessed or you saw. That's a scientific process. All right, so this is actually take two of this video. Take one, I played this video and it did not work well. It did not come through the audio of the computer like I wanted it to. So I'm not going to play it. I'm going to attach the link to your pacing guide for this video. It was just used for two reasons. Number one, to break up the lecture. Number two, to show you that there's a lot of things in science, a lot of things that we use today or play major or has major impacts on our lives today that was discovered by accident. And to me, that is what I find very interesting about science. And I say that to say this: when we start doing experiments, or you start doing experiments, just because your end result might not match what your predictions were, does not mean it's a failure. You may have actually discovered something that is even more impactful than what you originally hoped for. And penicillin is one of these situations. So I'll attach this link to the pacing guide. Feel free to watch it. I encourage you to watch it. It's very interesting to know kind of how penicillin was stumbled upon. All right, so that carries us into the branches of natural science. How are they organized? So they're organized in three main branches. You have biological sciences, physical sciences, and earth sciences. Biological sciences deal with anything that's living. It's life sciences, okay? Life sciences, excuse me. Some examples are botany, zoology, ecology. You also throw in biology in there. Anything that deals with living things, that's biological science. Physical science deals with matter and energy. We're talking about physics and chemistry. Those are the two big things. And of course, there's different types of physics and there's different types of chemistry. The last one, and the one that's probably forgotten for most people, not people in the science world, but most people outside the science world, would be earth sciences. And these are geology, or some examples are geology, astronomy, meteorology. Those are all branches of science as well. So as you can see from this little chart, there's a lot of different interests within science. So science sometimes gets a bad rap for being kind of dry, but I would argue that most of you could find something that interests you within science, just like you can in any other topic if you look hard enough and you really want to. All right, so two big definitions. The next couple slides, we'll have some definitions that you need to know. Uh, Pure science and technology. So, what is the definition of pure science? This is experiments to learn more about the world and also used to search for new knowledge. Technology and science, right? Technology and science is the application of science for practical uses. Engineers apply scientific knowledge and methods to design products people use. Okay? The process of using technology and science is the production of technology, your cell phones, your laptops, your tablets, all those things. Okay, science drives those to evolve, to change, to adapt, to become better, to become smaller, to become more powerful in a short period of time. Right, so two very, very, very big, goes back to one of our key ideas, scientific law and scientific theory. So you're going to have here on the slide, you have the overall definition of both. Then I'm going to point out two sub-bullets to the main bullets that is really important for you to know. So if you are currently writing notes, get ready to write. It's not going to a lot, but I do want you to write something. If you're not writing notes and you go back and watch this later, pay close attention to this when you rewatch it, okay? So a scientific law is a descriptive statement or equation that reliably predicts events under certain conditions. This is what I want you to hammer home about scientific law. A scientific law tells us how something works. Let me say that again. A scientific law tells us how something works. In contrast, or not really in contrast, on the other side of it, a scientific theory is a system of ideas that explains many related observations and is supported by a large body of evidence acquired through scientific investigation. Or you can say scientific theories explain why something happens. That's important. Let me say that one again. Scientific theories explain why something happened. So a law tells us how something works. A theory tells us why something works. Okay? Theories tell us why something happens or why something works. A law tells us how something works or how something happens. So the three theory tests. So in order for a theory to be valid, it must pass three tests. These three tests include that they must explain observations clearly and consistently. The experiments used to support a theory must be repeatable, and you must be able to predict results from a theory. In class, I really kind of focus on, and they're all three equally important. I'm not saying that this middle one is supreme importance, but I think it's one that's kind of overlooked, especially with high school students, talking about being detailed with your lab notes. Okay, when you're doing an experiment, or if you're doing something, you're taking notes over a process or whatever it is you might be doing, to be detailed with your with your steps, with the conditions you're doing it in. For example, let's just say we were doing a slime lab outside. We were making homemade slime, putting food coloring in it, all that fun stuff. And when we were doing it, a random lightning storm blew up with 8 bolts of lightning, and the humidity percentage jumped from 60 to 80% in a span of 15 minutes. And this is all after 3:30 in the afternoon on a mostly cloudy day. You get where I'm going with this. So if our experiment that we were doing was making homemade slime, and we wanted it to be repeatable, then we need to be sure that we write down all the conditions and things that are going on. The one aspect of the a hypothetical situation that I just described would be the lightning storm with 8 bolts of lightning popping while we were doing this experiment. That's kind of hard to replicate. So that would be hard for that experiment to be repeatable. So when you start taking notes for lab processes, whether it's a classroom demonstration or your own that you're asked to do, be very descriptive. Okay. I'd like to do an activity over this. I'm trying to think the best way to do it virtually. So stay tuned for that one. All right, so these will be the questions that will be included in the video form that is on your pacing guide for the week. Be sure you complete that. If you have any questions, let me know. Again, you can rewatch this video as much as you need. It'll be on the YouTube playlist that I'll share with you, along with on the pacing guide. It's on my YouTube channel. So if you didn't take notes, you missed something, pause, rewind, go back, watch it again later, whatever. If you have questions, let me know. And if not, we will see you all later. Thanks.